Hi everybody, we're talking about functions and we're going to talk about function input. And we're going to use our previous video's example, which is the user-defined function average list. So we write def to define our function, the average list name, and the parameter we want to take into and work with in our function. And this function just calculates the sum of the numbers in the input list, the length of the list, which is the number of elements in the list, and the ratio is just the mean, and we return the mean from this function. The question is then, how do we get numbers into our number list? So we want to pass our list of numbers into this function. There are several ways that we can do this. And one way is to specify the parameter and pass the argument directly into the parameter. So in this way, we know which parameter receives the list of numbers, and we see which kind of numbers we enter into the number list parameter. So we do this by just setting the parameter equal to the input. And you can do this with integers, decimal numbers, and you can also do this with strings. But then with strings, you can't do any calculations with it as such. And then we put the mean which is returned from this average list function into the mean variable that we have used here. And we want to print the mean is and the mean of these numbers. So let's just run this cell to define our function, and we run this cell to get our mean. We also have to run our cell to get the mean just by specifying the argument directly into the parameter. So if we run this cell, the average list function is called with these three numbers in a list as the argument, and this will be put into the first parameter listed in our average list function. But we only have one parameter, so we know where this list will go. So yeah, we ran this and we see that the mean is 2. So here we could change this and Control Enter to run, and we would get a different mean. But let's get it back, and we can also have an argument as a variable name, or a variable name as an argument, and put this into the parameter to be used in the function. So here we just put the list 1, 2, 3 into the variable input list, which is a list variable or from a class list, and we call the average list function, and we would input whatever we have put into the input list variable into the number list parameter. So if we run this, then we get the return from the average list function, which is mean, and the mean is 2. So for example, if we change this to 4, then we see that the mean is 3.0 because that's the average of these numbers. And we could also pass the argument in without specifying the parameter name. And then we put 1, 2, 3, the list of numbers, into our input list variable, and we just pass the input list variable, the argument, into the average list function. And because the average list function contains only one parameter, we know where the contents of the input list variable would go. So if we run this, we see that the mean is 2. We can change this as well, and the mean of 1, 2, and 6 would be 3. What if we have 2 parameters? In this case, we have defined a function called order, and this takes 2 parameters, num1 and num2. And the function uses the contents of num1 and num2, the parameters num1 and num2, as such. If num1 contains a bigger number than num2, then we would print num1 is larger than num2. And if this is not true, in the case that num2 is equal or greater than num1, then we would print else num1 is not larger than num2. And here we use positional arguments because we can call the order function here and just specify the numbers that we would like to put into num1 and the num2 parameters. So here we just specify some literals, and we can run this, and of course we have to run the function definition before we use the function itself. And here we see that 100 has been placed into num1 and 5 has been placed into num2. So num1 was 100, so here you have 100 greater than num2 was 5, so 100 greater than 5. This is true, so then we run this piece of code and print num1 is larger than num2. But what if we switch around these arguments, these literals? Then we call the order function, and we have 5 in the num1 parameter and 100 in the num2 parameter. And then if we run this, we see that num1 greater than num2 is actually false because 5 greater than 100 is not true, so we do not run this piece of code. We run the else piece of code. And then we say num1 is not larger than num2. Positional arguments can also be used with variables. So if we define one variable as my num1 and we place 100 into this, and we define my num2 as 5, then we call the order function, and my num1 now contains 100, my num2 contains 2. So yeah, here we have to run our variable definitions. So then we have num1 is larger than num2. And we can also switch around these variables as arguments. So we switch around these variables as arguments, and we run this, and now my num2, what's in this? It's 5. It will be placed in the first parameter, what is in my num1, it's 100. So that would be placed in my the num2 parameter. So, and when we run this, we see that num1 is not larger than num2 because my num2, which is 5, was placed in the num1 parameter. But in the case that your function contains several parameters, it might be somewhat difficult to remember the order of each parameter. So then we can use something called keyword or named arguments. And in this case, we have the name that matters. So we can call the function order, and in the first parameter, num1, we place 100, and in the second parameter, we place 5. And this increases readability for your future self, or if someone else is reading your code. And you can also supply these keyword arguments as variables. So in this case, we have my num1, which was defined up here. We have placed 100 in that. And we have my num2, which contains the number 5. And if we run this, then yes, num1 is larger than num2 because the larger number was put in my num1. And the one extra benefit of keyword arguments is that the order does not matter. So if you have num2 here equals whatever is in my num2, you can, after that, state whatever is going into the num1 parameter. And in this case, the contents of my num1 variable should go into the num1 parameter. And we just run this, and indeed, num1 contains 100 because my num1 contains 100. My num2 contains 5, so num2 is 5. So num1 is larger than num1. And one extra benefit is that functions can be supplied with default values. So if you do not specifically express what value this parameter should have, it gets a default value. So we have defined a function here, which we call exp or exp, and we provide two arguments, one in the base parameter and one in the exponent parameter. And the result is base raised to the exponent, and we would return the result. In this case, a shorter method could be to just return this. But we shall see that later on. But here we have exponent has a default value of 2, so we, well, the default is to square the base number. So if we just Control Enter this cell, then we can use our exp function, and if we just provide one argument, this will be put into base. So then we would get 2 or 8 to the power of 2, which is 8 by 8 is 64, or 8 times 8, 64. And we could overwrite the default value by assigning a new value to the parameter. So here we have exp, base equals 8, and exponent equals 4. then we have 4096. Or we could just skip the keyword arguments here. We could use positional arguments, and we would get the same result. We are now done with the input, and now we can focus on the function output. And whenever you have this return from the function, which makes the function return a value, then we can store the output or the return value in a variable. So in this case, we have the exp function from before. We have base 10 to the power of 3, and we get 1000 put into the res variable. And the output of a function can also be used in another function call. So for example, here we have our exp function, which it returns 1000 as we saw. And this is a part of the parameters or the arguments for the sum function. So in this case, we have 1000 plus all these small numbers, which sums up to 1044. And we can also use the return value from the function in an expression containing multiple function calls. So here we have exp base 10 to the power of 3, and we have exp base 8 to the power of 3, and we divide them and take the ratio. It's 1.95 approximately. And we can also have a return value from a function as a part of a conditional expression. Here we have defined base as 10, exponent as the number 3, and here we have our conditional expression. If exp or exp base exponent, base contains 10, exponent contains 3, so it's 10 to the power of 3. If this is greater than or equal to 1000, then this is true. And we saw that 10 to the power of 3 is 1000, so this is greater than or equal to 1000. So then we should print equal or larger than 1000. If we had only 2 here, we would have 10 to the power 2, which is 100, and it's not greater than or equal to 1000, so this would be false, and we would print the else statement instead. And a value returning function can return either a value, variable, or a calculation. And here we have defined our function as the exp or exp name. We have 2 parameters, base and exponent, and we put the base to the power of the exponent in the result variable, and we return the variable. And if we run this, we get 64. Or if we have 3 to the power of 2, then we get 9. We can return the calculation directly without specifying a temporary variable to return, and this would give you the exact same result with using fewer lines of code. And we can have a definition of a function which we call check answer, and it takes one parameter or one argument put into the answer parameter, and then we check whether the contents of this parameter answer is strictly equal to yes. So remember, these 2 equal signs tests whether or not the two sides are equal. So in our case, we would like to call our function and and our argument is yes, which is put into the parameter. So then we should return true. And a value returning function may return more than one value. And here we define a function called min-max, and it takes a list of numbers put into the parameter numList. So then we would use the built-in functions min and max to get the minimum or the lowest number and the maximum number, the highest number, and put these into two different variables inside the function. And then we should return two numbers. And if you have a list of numbers, this list is put into the int list variable, and we call our min-max function returning two numbers, supplying our list of integers, and put the return value in our res variable. And now we can print whatever is in our res variable. Well, of course, again, I have to remember to run the function definition. And sorry for the voice crack there. And we see that when we print our result, we get the minimum value and the maximum value, and they are in a tuple. Or in a tuple, as I usually say. But these numbers, the minimum number and the maximum number in this tuple, can be accessed by the index value. And remember that the first value in a tuple is indexed by 0, and the second is then indexed by 1. So here we would like to print both numbers, the number indexed by res 0, or the 0th index, which is 4, and the res value at index number 1, which is 93. We can also assign a variable name to each return value, and here we have res1, we have res2, and we run we call the min-max function, supplying our list of integers and putting the return values into these two variables. And we would like to print whatever is in our res1 and res2 values or variables, and we get the same output. We also have to talk about immutable and mutable arguments, because values or variables which are assigned to a function as arguments can actually be changed. And we have seen in previous videos that integers, floats, booleans, strings, and tuples, they are immutable, so they will not be changed. Whereas lists, they are mutable, so they can be changed by the function, even if the function is not directly overriding the variable which has been placed as an argument. So if we have an example here, we have a change value function. So def to define a function, change value as the name, and one parameter n. And if n is negative, then we should set n equal 0, and we should return the new value of n. So if we have a variable outside of the defined outside of the function, and we give it the value -10, we can run the change value. Well, here we have to do like this because the change value name is like this. So, and remember that we are passing -10 into this function, and we would like to print whatever the new value is. And it should be 0, because if we have -10 here, then we run the if sentence, -10 less than 0. That's true. So this is true. Then we run this sequential line of code. So we set n equal to 0 and return 0. But if we now call the value, or check the value of n, we have -10 here. So even if we used the same name for the argument variable and the parameter, then the variable defined outside of the function was not changed. But lists are mutable, so if we define a change list variable, no, function, then we write def for define our function. Change list is the name of the function, and within the parentheses we have our parameter, which is called num list. And for each element in num list, we should check whether or not the num list, or the element at index number k, is less than 0. And if it is, then we should set it equal to 0. And the function should return the num list variable. So if we define a list here as int list and provide some numbers, we have 6 numbers here, where of which 2 are negative, and we would expect those to be changed up here, right? So because if these are negative, then num list less than 0 would be true, and the value at that index number should be set equal to 0. So if we provide our list as an argument, then we can run this and put the output, which is num list, into this res variable. So now we have put this into here, and for each element in our list, then we have gone through this check whether or not it's the number is negative, and if it is, then it's supposed to be changed to 0. So let's print both our lists, and we see that the res variable contains the change list from which was stored in num list, but just by providing the int list as an argument to our function, the argument list has also been changed. So this is somewhat dangerous here in Python. So if you would like to make sure that the argument list is not changed by the function, you can get around this problem by making a copy. So remember that you provide the int list, which is a list of these numbers, is placed into here, num list. So num list now contains 5, -2, and so on. But to make sure that whatever we do with num list does not affect the list provided as an argument, we can just define num list is its own copy. And if we run this, we can see that I definitely did something wrong, because change list is not defined. It's here. That's a noob mistake. And now we have correct verb or correct function call names, and we have run this, and it's okay, and we can print whatever is in the result from stored in num list put into the res variable, and we have the initial list of integers. And we see that by doing this little trick, the list which is provided as an argument has not been changed. It is also quite important to make your code robust. So remember from last video that one of the reasons why we use functions is that we can provide secure cells of code or parts of code which do not interact with other parts of code, for example. And in the meaning that variables defined inside the function does not affect variables outside of the function, except for some cases, as we had seen in this video. So, for example, we have to implement functions that catches all scenarios. And this is quite important. So if we have an example here of a function, and we define the function check number, we check two numbers. We have two parameters here, num1 and num2. If num1 greater than num2, return 0. And we check our check two numbers with our check number variable function, and we put 20 in num1 and we put 10 in num2, and we check, is 20 greater than num2? Yes, then it should return 0. So if we run this, we have 0. But if we switch around with these positional arguments, we get 10 in num1 and 20 in num2. And when we run this if sentence, we have the statement 10 greater than 20. And this is false, so then the function will return none. And the none type is a class, and you cannot calculate with this class. So if we try to multiply none with 100, then we get an error. So here you have to rather add this else statement, which catches all the cases where this is not true. So if we run the check number function with 10 and 20 in num1 and num2, then 10 greater than 20 is false. So we do not run this piece of code. We run the else piece of code, and we should return 1. And which have it. We are now coming to the most important part of using functions. I brushed a bit upon this earlier on, but we have to talk about a variable scope. And variables which are created within the function is known as a local variable, because they are not accessible outside of the function. So here we have a function definition, and you have to define the function. Exp is the name of the function, and the function takes one argument placed into this base variable. Inside of the variable or the function definition, we have this myPower variable, which is set equal to 2. So kind of we are putting 2 into this myPower variable. And we should return base to the power of myPower. So this is the base to the power of 2. So we put 8 into base, and we run exp base. So that would return 8 times 8, which is 64. But if we now try to access this value in myPower outside of the function, then we get an error. So this is quite good practice, because variables which you need within a function should not be accessed outside of the function. Because whenever you have a program with a lot of functions, then you would have a lot of function names. And if all these function or variable names, I mean, so if all these variables were accessible from all other parts of your code, then sometimes variables are called the same name, and then you would have a huge problem, because several functions would access the same variable and change the value in it. So this is why it's good practice to use functions. Well, variables that are created outside of a function is known as a global variable. And all functions can access this variable and use its contents. But if you have a lot of global variables, then you have many sources of errors, and if the variable is changed unintentionally. So in this case, we define power outside of the function, and then it's a global variable, and a global variable can be used within every single function. So here we pass in 2 as our base to the power of whatever is in the power variable, which is 5. So we have 2 to the power of 5, and that should be 32. And it's good practice to put your code in variables, not in variables, in functions, and then call these functions from a main functions. Later on, we are going to expand on this and define a conditional sentence. If name equals main, then you run the code. But for now, we just do this. So here we have defined 2 functions which we would like to run, and one is print greeting. It's just printing hello everybody. The second one is print goodbye, and it's just printing goodbye everybody. And here we have defined our main function, which is calling other functions. And then we have to call the main function to run everything. So if we do this, well, then we print, this is an example of good organization of code. Hello everybody, goodbye everybody. And we could of course print or put this into a function as well, but it's just a print statement. And last but not least, your future self will be quite grateful if you document your code properly. And here you can define the function you would like to document or use, of course. And here you have the exp function with base and exponent as the parameters. And here in triple double quotes or triple single quotes, then you could put your documentation. And this documentation is quite handily accessible, because if you define this function and you of course check that it works, but whenever you have this triple quotes and this text, you can access this help text by using the help function, and the argument for this help function is a function. So if we run this help exp, then you get whatever is in here, you get printed here. So then it's quite easy to get help on your own user-defined functions.